All right, we got a very tiny little foldable right here. All right, so whenever we have lists of numbers, these always start at x is 1, or I will probably say time 1 a lot, every time. So looking at this first one here, we have 2, 5, 8, 11. So 2, 5, 8, 11, these are the numbers that we got, right? Now 2 is my first number. 5 is my second number. 8 is my third number. 11 is my fourth number. So what's gonna be the fifth number? Very good, it's 14 because we are adding by 3. Now at this point, you guys should be pretty confident with the whole recursive and explicit thing. So let's see what you got. All right, so hopefully you got f of n equals f of n minus 1 plus 3 for the recursive, given that you start with f of 1 equals 2, right? We don't do the opposite with recursive. The opposite occurs when we talk about the explicit. So we start with 2, we are adding 3. We start with 2, we are adding 3. And then we have parentheses n minus 1, because when we write the explicit, we want to write the opposite of this 1 here. All right, so in this next problem, please change that 2 to a 3. That would be great. So 3 is my first number, so it's my first number 3. Second number is 6. Third number is 12. Fourth number is 24. So what is going to be your fifth number? Should be 48. All right, now go for gold. Write the recursive and the explicit. All right, so hopefully you got f of n equals f of n minus 1 times 2. We are timesing 2 as we go down our table. We start with 1. We start with 3. That's the recursive. For the explicit, it's basically focusing on the right side, right? You start with a 3. You're multiplying by 2. And then we're going to have exponent n minus 1 because we have to account for the opposite usage of this time 1 here. You always want to do that. And that's, again, opposite is only for when we deal with the explicit. All right, I want you guys to try these two totally on your own, and let's see what you get. All right, so in this next one, 15 is your first number, 11 is your second number, 7 is your third number, 3 is your fourth number, -1 would be your fifth number. You are subtracting by 4 as you go down this table. So in the recursive, that means we're going to have f of n equals f of n minus 1 minus that 4, given we start with f of 1 equals 15. For the explicit, again, it's all about what you're doing as you go down. So explicit is we started with 15, we are subtracting by 4, we do regular size and minus 1 because we have to account for this time 1, and we got to do the opposite when we do that. In this next problem here, we started with 64 as our first number, 32 was our second number, 16 is our third number, 8 is our fourth number, which means 4 would be our fifth number. We are dividing by 2 as we go down this table, but we got to write it as times 1/2. We got to do secret division. So this gives us f of n equals f of n minus 1 times 1/2, given f of 1 equals 64, right? We start with 1, we start with 64. For the explicit, once again, it's about what's happening as you go down the table. So the explicit, we started with 64. We are dividing by 2, aka timesing by 1/2. And this is going to be exponent size because it's geometric. We are multiplying, and we do n minus 1 because we have to account for time 1, and you always do the opposite of your first x. All right, that's the end of this video. Go ahead and glue this in, and have a great day.